Now let's move on to the topic called as electric potential at a point due to an electric dipole. So you can parallelly see how the electric dipole and its potential is defined and depicted over here. At first, let us consider the two charges, that is minus q at A and plus q at B. So you can see here minus q is at A and plus q is at B, which has been separated by a small distance 2d. So here you can see the distance between the two charges at a point A and B, which constitute an electric dipole and its dipole moment. So this is indicating about the potential due to a dipole. So you can parallelly see how the dipole, that is the electric dipole, is having its impact around the electric field over here. So let P be the point at a distance r from the midpoint of the dipole O, and this theta is considered to be the angle between this P and O, and you can see the axis of the dipole OB. Further moving, let R1 and R2 be the distance of the point P from plus Q and minus Q, which is considered to be the charges. So in order to find the potential at a point P due to the charge plus Q, the equation is as follows. That is 1 divided by 4 pi epsilon naught into Q divided by R1. So this is the potential at a point P due to the charge plus Q. In a similar way, if we consider the potential at a point P due to the charge minus Q, then the equation will be 1 divided by 4 pi epsilon naught into minus Q divided by R square. So this is indicating about the potential at a point P due to the charge minus Q. So in order to find the total potential at a point P due to the dipole, the equation will be equal to one divided by 4 pi epsilon naught Q into, so V equal to 1 divided by 4 pi epsilon naught Q divided by R1 minus 1 divided by 4 pi epsilon naught Q divided by R square. So in order to find out the total potential at a point P due to its dipole, we need to calculate in this way. From this, we can take out the common terms Q divided by 4 pi epsilon naught outside. So the remaining terms will be 1 divided by R1 minus 1 divided by R2. So this Q is indicating about the charge, whereas R1 and R2 is indicating the distance, and epsilon naught is indicating about the permittivity of free space. So we can mark this as equation number 1. Now applying the cosine law, that is R1 square equal to R square plus D square minus 2RD into cos theta. So before we apply the logic of cosine law, let us consider how this logic is. So we have the first equation, that is V equal to Q divided by 4 pi epsilon naught into 1 divided by R1 minus 1 divided by R2. Applying this to the first equation, So this equation will become R1 square equal to R2 plus D2 So this equation will become R1 square equal to R square plus D square minus 2RD cos theta. So from this equation we need to take out R2. If you take R2 from the previous equation, this equation will become 1 plus D square divided by R square minus 2D cos theta divided by R. Since D is very small when compared to R, so this term D square divided by R square can be neglected. So if this term gets neglected, then the equation will become R1 square equal to R square into 1 minus 2D cos theta divided by R. Now, taking the square outside, it will become 1 divided by 2 as a power. So now the equation will be R1 equal to R into 1 minus 2D divided by R cos theta the whole power 1 divided by 2. This can be also rewritten as 1 divided by R1 equal to 1 divided by R multiplied by 1 minus 2D divided by R cos theta the whole power minus 1 by 2. So now let's see how the next step is all about. By using the binomial theorem, we shall neglect the higher powers. So this was the previous equation which we got before. So 1 divided by R1 is equal to 1 divided by R multiplied by 1 minus 2D divided by R into cos theta the whole power minus 1 by 2. So applying the binomial theorem, this will become 1 plus minus of 2D divided by R cos theta. So this term is indicating A and this term is indicating X. So applying this formula over here, it will become this A is 1 and this N indicates minus 1 by 2 plus this N, that is minus 1 by 2, A to the power of minus 1 by 2 minus 1 multiplied by X. Over here X is minus 2D divided by R cos theta. So cancelling 2 and 2. So minus into minus becomes plus. So this term can be written as 1 divided by 1 to the power of 1 by 2. On cancelling these terms, we will be getting 1 divided by 1 to the power of 3 by 2 multiplied by d by r cos theta. So this term will be 1 plus this term will become 1. So we will be getting d divided by r cos theta. So from this we yield the second equation, that is 1 divided by r1 equal to 1 divided by r multiplied by 1 plus d by r cos theta. Similarly, let us find out r2. So r2 square will be r2 plus d. So this is the equation, that is r2 square equal to r square plus d square minus 2rd cos theta. Over here cos of 180 minus theta. This can also be written as r2 square equal to r square plus d square plus 2rd cos theta. So here theta is indicating 180 minus theta, it becomes minus cos theta. So this minus and minus, if it is going to be multiplied, it becomes positive, that is plus. Taking r2 outside from the above equation, so this equation will become r2 square equal to r square multiplied by 1 plus d square divided by r square plus 2d cos theta divided by r. Since d square divided by r square is negligible, we can delete it off and neglect it. So now the equation will become r square term, and if we take the square to the power, it becomes r2 equal to r multiplied by 1 plus 2d divided by r cos theta the whole power 1 by 2, which can also be written as 1 divided by r2, which is equals to 1 by r into 1 plus 2d by r cos theta the whole power minus 1 by 2. Now applying the binomial theorem and neglecting the higher power, this equation will become 1 divided by r2, that is equal to 1 by r multiplied by 1 minus d by r cos theta. So substituting the second and third equation in the first equation, it will be, so this was the first equation, so we got to substitute equation 2 and equation 3. So instead of 1 by r, this term will be substituted, and instead of 1 divided by r2, so we'll be substituting this term. So now this equation will become v equal to q by 4 pi epsilon naught 1 by r into 1 plus dr cos theta minus 1 minus dr cos theta. Multiplying minus, it becomes minus 1 plus dr divided by cos theta. Now we can cancel plus 1 and minus 1 over here. Now the equation will become b equal to, this q will be there, this 4 pi epsilon naught into r, since it has been r square, because in the bracket we have 2 times of 2d cos theta divided by r. So if we multiply, it becomes r square. So this q2 into d can be substituted as p, which is over here. That is the electric dipole. So now the equation will become 1 divided by 4 pi epsilon naught p into cos theta divided by r square. So in terms of this electric potential at a point due to an electric dipole, let's check out these special cases. When the point P lies on the axial line of the dipole on the side of plus q, then the value of theta will be 0. If you substitute 0 in theta, it will become cos 0 equal to 1. So this term will become 1. Therefore, we will be getting v equal to p divided by 4 pi epsilon naught into r square. The next special case will be when a point P lies on the axial line of the dipole on the side minus q, then the theta value will be 180 degree. Substituting cos 180, it will become minus 1. So this term will become minus 1. Therefore, the equation of v will be minus of p divided by 4 pi epsilon naught into r square. In the same way, when a point P lies on the equatorial line of the dipole, then theta is equal to 90 degree. So 90 degree will be cos 90, it becomes 0, then the whole term will become 0. So v equal to 0.